welcome to podcast.init, the podcast about Python and the people who make it great. I would like to thank everyone who has donated to the show. Your contributions help us make the show sustainable. When you're ready to launch your next project, you'll need somewhere to deploy it, so you should check out Linode at linode.com/podcastinit and get a $20 credit to try out their fast and reliable Linux virtual servers for running your app or trying out something you hear about on the show. You can visit our site at www.podcastinit.com to subscribe to the show, sign up for the newsletter, read the show notes, and get in touch. To help other people find the show, you can leave a review on iTunes or Google Play Music, tell your friends and coworkers, and share it on social media. Your host, as usual, is Tobias Macey, and today I'm interviewing Kenneth Loafman about the Duplicity project. So, Kenneth, could you please introduce yourself?
Yes, hi, this is Ken Loafman. I've been a programmer for over 50 years. I'm retired now, officially. This is my avocation as well as my vocation. So really that's about it for now. I've gotten experience in everything from embedded systems all the way up to supercomputers. So it's out there, I've talked to it.
Yeah, having been in computing for that long, I'm sure it must be pretty astounding to look at the evolution over the years because there's been such drastic shifts in capacity and capability. Though I'm sure that, the more things change, the more they stay the same.
Yeah, that is absolutely the truth. The funny part is that there seems to be a 10-year, roughly 10, 12-year cycle on terminology. Some of the things I learned earlier have been resurfaced and resubmitted or re-brought out. I don't know what you want to call it, but under a different name. I had forgotten what we had called it earlier, but about 15, 20 years ago, I had to buy a book, $55 textbook, because somebody used the term red-black tree. It was something I was familiar with, but not under that terminology. So, like I say, I think some things get recycled in this field. So that's just a fun observation.
And do you remember how you first got introduced to Python?
Python came about, a friend of mine and I were working on some side projects. At the time, I was working in C++, and he introduced me to Python. I got interested in it, and this was roughly 2000, 2001. My first Python version was 1.5.2. It was very simplistic back then. Mainly, I've been doing Python since then. I've done some work in Java, and I've done some playing around with C++ 11 because of all the interesting things they have in there. But I'd say 99% of the stuff I've done in the last 17 years has been in Python.
And the reason that I'm talking to you today is because you're the current maintainer of the Duplicity project, which is a backup system written in Python. So I'm wondering if you can share a bit about the history of Duplicity and maybe describe a bit in more detail about what it actually is.
I took over Duplicity in 2007 from a man by the name of Ben Escoto. He was actually a student at the time going to Stanford, and he had written it, had gotten tired of working on it, and put out a note on, I've forgotten the name of that mailing list. It may have even been a Usenet list back then, but he asked for somebody to take over the maintenance, and I did. He and someone by the name of Jinty, Jinty, I never found out his last name, had been working on the project together. I took over maintenance in 2007, and it's gone slowly since then. I found out that I didn't quite have the time I thought I had to work on this stuff. So it ended up being a background project, and quite often went for a week or two at a time without me even having time to touch it. Especially during the 2000s, I was in a couple of startup companies, and those can be rather time consuming.
That's a nice way of putting it.
Yeah, it can be time-consuming, and it was supposed to be a background project. It was already working fairly well, and a lot of the contributions over the last 10 years since I've had it, it's been 10 years now, short 2 months. I was just looking at the changelog, and the very first entry I have in the changelog is 2007, May the 24th, so this is 10 years minus 2 months, roughly, that I've been working on it. It is intended to be backup system to support multiple backends. And the main thing is that it supports really dumb backends. Right now we have about 20 different backends: WebDAV, FTP, FTPS, SSH, SCP, SFTP, Amazon Cloud, a couple of versions of those, Backblaze, and quite a few others. Most of the backends I didn't write, and I barely know how they work, but the requirements for Duplicity are fairly easy, and that is they must be able to list the directory. They must be able to put a file, to be able to get a file, and to be able to delete a file. And we don't ask for anything else. So all of those protocols that I mentioned can do more than that, but we require actually less than they can provide. The reason for the simplicity is so that you can have multiple backends. Now, Duplicity can do much, much more and can probably work better if we expanded the possibilities of the backends to, for example, we could put the file out there in a partial form and then finally rename it. That would be one of the handiest things to have, because sometimes things fail and we don't know it. The protocol returns a non-error situation, a success, and we think it has succeeded and that the file is incomplete for some reason. So that kind of thing, if we had more control over the back end, we would have, I think, a tighter situation. But the major thing is it does encryption as it works. It does take what we call bandwidth efficient incremental backups. In other words, we use the same algorithm as rsync does. We take a look at the file, and the part that has changed, the block that has changed, gets transmitted rather than the entire file. And an incremental is built up of a set of those blocks for each file, plus any new files, plus any deletions, etc. So what we have is a slightly more efficient way of doing incremental backups of some fairly large files, like database files, virtual machines, that kind of thing. We can back up just the parts that's changed, and that saves a lot of bandwidth. And really, that's our main benefits. You can turn off the encryption, you can turn off compression. We have a lot of options to control what's going on, how many backups you keep, how many levels of backup you keep. We can tell you by time whether to keep a backup, or by how many backups you have, that kind of thing. So it's fairly mature right now. There are parts that I would like to rewrite because of the error handling. The problem is the use of iterators got quite involved in the original, and I haven't gone back to fix that. Sometimes you get iterators that are nested quite deeply, and when you have an error, it's difficult to, well, most of the time it's impossible to recover from the error. If you can retry the error and have it go through, then yes, that's recoverable. But if you fail during the iteration, you've lost essentially everything, and you have no way of going back through and reinitializing the various iterators that you just popped out of. So that's a weakness of Python, and it's probably a weakness of other languages that have iterators. I think the future of Duplicity is probably going to be a complete rewrite. I would still stay in Python. I might put a few things more into C, but right now Python is very good about its C interface, and so the time-consuming items are the encryption and the libart and the rsync algorithm, and both of those are already external modules in C, so we can use those and get the speed we need. Very little that Python needs outside to make it faster, because we're still limited by bandwidth and by, bandwidth mainly.
Yeah, a lot of times when people start talking about the speed of Python, they are looking mainly at just the computational capabilities, where a lot of times the actual slowest part of your program is dealing with network latencies and disk I/O, things like that. And so I imagine that if and when you do get around to a rewrite, you could probably make some fairly good use of the async capabilities that have been introduced in the newer versions.
Yeah. Right now, I haven't investigated Python 3 yet, but I understand it still has the global interpreter lock, and that's not too much of a problem, but it would be an impetus for me if I was trying to truly optimize things. I would probably, if I was going to do a complete rewrite, I would do it in C++, just knowing that I wouldn't have to worry about some interpreter lock or something like that. But I doubt that that's ever going to happen. It's just, I believe we can get 98% of the speed we need out of Python and judicious use of threading or multitasking.
And going back to your point about the fact that the backends for Duplicity are largely just sort of dumb storage, I think that that is at least a great deal of the appeal for myself, because a number of the other backup solutions that you look at require a client-server capability where the server is what encapsulates all of the intelligence, and so it makes it a little bit more of a setup overhead from an operational perspective, whereas with Duplicity you can just put it on a host, run the backup, and then not have to worry about setting up any additional pieces, particularly if you're running the backup on ephemeral instances. So for instance, one of the things that I'm using at my work is setting up an instance in EC2, running Duplicity to back up the files from a different host, so doing a database dump, and then running the backup to S3, and then terminating the instance without necessarily having to worry about keeping that around for perpetual capability. So it simplifies the overall architecture without having to set up that client server and maintain two different pieces.
Yeah, there is a lot of that kind of simplicity that is needed. I think the only backend that actually uses any kind of client server is the rsync backend itself. But even that is a very simplistic use of rsync. So all the work is done inside of Duplicity, and so it's merely a copy of the file, not through the rsync protocol, not a rsync to a copy of the file.
And at face value, the idea of backing up files generally seems pretty straightforward because, conceptually it's just moving files from one location to another, but there's a lot of incidental complexity that comes into play when you start thinking about the long-term requirements of those backups, making sure that they are valid, making sure that you can restore them, the fact that files change from backup to backup, so being able to do the incremental backups that you mentioned. I'm wondering if you can describe a bit about the internal architecture of Duplicity and maybe describe how it's able to handle the wide variety of use cases that it's put to.
Okay, internal Duplicity is actually fairly simple. It uses the librsync module and signature file to find essentially the areas of whatever file is changed. Now, if you're presenting it with a new file, the effect is an empty signature chain, and a comparison against that yields just additions. So the whole process works the same regardless of whether it's a new file or an old file. And then it has the setup to call the back end, and the back end will only do all the what they call the diff-tar files, which are really just our special usage of tar to put together the same directory structure and so forth of the data. And then we have the signature file, which is also a tar file, also in the same structure. And there's a manifest file, which helps us. The manifest file is really not a very sparse manifest. Basically, it tells us what file the volume started on and what file the volume ended on, and where it ended, that kind of thing. So that when we're doing recovery, we can go, instead of reading 1,000 tar files, we can go to the one or two that we need to use to recover the file. It has exactly one thread possibility, and that is the async upload. Once you have a diff-tar file built, you can send the file up while we're working on the next one. And it seems to work pretty well. It's still a case where a lot of times if the file is too small, you'll have volume size is too small. You'll be building the file so fast that basically it becomes a burp, and a burp of CPU activity and burp of network activity. That's where we need to have some optimization, because we really do need to keep things sped up, things flowing through the network on a continuous basis if we're going to get this thing optimized. Like I say, if you look at it internally, it's going to have some gotchas. It works pretty well. It needs work, definitely needs work on error messages and error handling. Error messages are still, for the most part, tracebacks, Python tracebacks with some cryptic little error message, which, if you don't know Duplicity, is pretty freaky. I'm sure that some people get freaked out. If you don't know Python, you get this dump of traceback, and you say, what the heck is that? And hopefully you go ask somebody and not give up. Usually it's some simple thing that can be fixed. It's really sort of getting into algorithmic details and all that. That's about really all I can say.
It's a good overview of how it works and the different pieces that put it together. For anybody who wants to dig deeper into the actual algorithmic pieces of it, I can add some references to the show notes. And if you have any particular sites or documentation that would help with that, I can add that in after we're done recording.
Okay, yeah. I think for somebody that really wants to look into it, we can do that very easily. There's a couple of sites that, especially the LIBarsing algorithm, I remember the guy's name. His last name is Poole. Supports that, and he's also a Duplicity user, or at least he is enough of a user that he submits bug reports and improvements periodically. We have several users that are very active improvements to the package. Like I say, all of the 20 or so backends were written by somebody other than myself. I wrote one of those backends myself, and that was it. The rest I have modified after having to study the protocol. Some, I'd say most of the backends have just performed. The original author has done enough to get by. And I would say, in general, the normal Duplicity user is either using it from a package like Deja Dup or from Dupli, and never really encounters any options outside of what he needs to get the job done. So, like I say, the backends are simplistic. They just seem to be working fairly well.
And you mentioned that the default configuration will encrypt the backed up files. So I'm wondering if you could just briefly discuss the importance of having those files encrypted, even if you are controlling the end storage location as well.
If you're physically controlling the storage location, like you have a large array of disks or something like that, USB drives, something like that, and you have good physical security, then there is no reason for encryption. As soon as I can get to that collection of drives which you have, which has no encryption, I now own your data. So, even if you are operating at home or in an office that is secured with security guards and so forth, encryption keeps anyone, well, it doesn't keep anyone, but it keeps most people from getting a hold of your data, even though you think you have physical control of it. Sending the data over network to something like one of the cloud services is normally done encrypted, so you actually have encryption on the data itself, and you have encryption via SSL. Well, one of the things I've been doing since I've retired is I've been taking some courses in ethical hacking, and I have learned just how pathetically easy it is to do a man-in-the-middle attack on a wireless connection. So I realized that anybody sitting outside my house or outside my business, if I had a powerful enough wireless and was using wireless to communicate from, say, a laptop in the meeting room to an unsecured server, they could decrypt the entire thing. It's just pathetically, the security is poor on wireless. It's a little better with Ethernet, again, going back to physical security, because that's really the only security. Well, I'll go back to the old saying. The only really secure computer is a computer turned off sitting in a vault that has no electrical access. Kind of useless data, but it's secure. So it's a hassle for a lot of people to think about doing PGP keys, GPG keys, remembering passwords, that kind of thing. There are a lot of password managers out there that could help with that. They are good. You give them a good strong password, and you don't really have to remember all of your passwords. If you wanted to encrypt everything with strong passwords, or if you wanted to encrypt everything with strong keys, that is very good. It can make it so that the only people that can decrypt your data is, well, potentially the NSA, but they probably have easier ways to get your data than going after your backups. So I would say that not encrypting your data is probably just reckless. There are, on your system, you probably do your banking, you probably do bill paying, you probably have credit card information, you probably have social security numbers, things written down about your parents, things written down about your children that you don't want out. You just don't want known to the wide world. And if you operate over the internet without encryption, then you really are opening yourself up to that kind of issue where just some stray person can get your data.
Given the fact that people are relying on backups for critical recovery or for, making sure that if they make a mistake that they can get back to a previous known good copy of something, the actual mechanism that's doing the backup needs to be fairly reliable. And so I'm wondering, what are some of the processes or tooling that you've got in place to ensure that you don't have regressions or sort of critical failures in the backup tool itself?
I have a set of unit tests. We currently only have about 400 or so of them. They don't cover most of the backends because the authors of the backends didn't write them, and I don't have access to the backend itself. That will help us keep away from a regression. Now, we have had regressions. We have had cases where a piece of code you got fixed, and then it got reverted back to its old form quite by accident. It hasn't happened more than 3 or 4 times, so I think that's a fairly decent statistic. When it does happen, we try to fix it quickly and get a patch out there, a release or something. Every time I do a release to the trunk of the Git repository on Launchpad, I run those tests, and I run a complete set of tests, no matter whether I consider it a minor change or not. I've been burned too many times by saying this is too trivial a change to test. I learned that way back a long time ago, just by the simple fact of blowing a 3-line subroutine, which was supposed to be a stub, to test another routine. I committed it, and it didn't work. And very simply, I misspelled a variable. So you'd think that a 3-line piece of code wouldn't be a problem, but it can be. And if you're putting it out there for people to use, and if you're doing backups that are sometimes hours and days long, you don't want to go to the very end and find out that we, the programmers, have introduced a bug that is going to mean that entire backup is no good anymore. So we test. I'd like to have more tests. In all honesty, we have quite a few of the functional tests are command line tests. In other words, we run the entire package. That helps some. I would like to have basically just a lot more testing, a lot more combinations of things like GPG options and access to a sample of all of the cloud services that we talk to so that we can actually test every backend that we put out. Right now, they go out, the author says, yeah, that works. And we say, yeah, okay, this is good. And it's just it's a trust thing on the back end. And mainly the tests that we do are for the core and do the back end testing enough to make sure that we still call the backends correctly. Help and testing would be a good thing for somebody to volunteer for if they're listening to this.
And what are some of the mechanisms that Duplicity uses to prevent data corruption during the backup itself?
Okay, during the backup, we take an MD5 sum of the volume, and we compare that to when we download the volume to make sure it hasn't changed. And we use gzip or bzip, depending on which option you choose. And that has fairly decent checks inside of it for corruption. And the actual encryption itself is another check. If it decrypts properly, then you have a good indication that it is that everything is good. What we also have, what really is the kicker, is the fact that we have the signature files Those are very simplistic. Those are very kind of automatic things that happen. But when you verify the backup, you look at the signature files and you verify that the signature files are valid, and you can do a data comparison if you want. And verification is really the only way to make sure that your backup is secure, is 100% secure. Because of network errors, we won't detect that. So the only sometimes network errors happen because of a faulty router, faulty configuration. Network errors happen much like disk errors. 1 in a few billion are going to have just natural errors that somehow are not detected. So what will happen is we will get a file on the remote system that has been corrupted somehow. It will fail its checksum and will stop. Or if you give it an option, it will try to ignore the error and continue onwards. If it's only a minor error, in other words, a file is corrupt somewhere inside the tar archive, then you might get lucky and we might be able to continue. Sometimes a single bit error on an encrypted, zipped or zipped file can cause the rest of the file to be totally useless. So when I say verify, I mean to verify the backup, you have to verify the data in the backup, which means you download your entire backup and compare it against what you just did. And most people do not do that. So I can't think of anything else that we do, but the signature file itself is the main thing. If you verify and the signature says that the file is different than what it was, then it's like the MD5 sum, only on a very much smaller scale block of data. So you have a good indication that your backup is bad and you can redo it. There's another option, part 2, which will create ECC files for you, which allow you to rebuild the file in case of data corruption. Now, that adds a high cost. It's like a RAID. It'll add like 20-25% of your backup size. It'll increase it by 20-25%. But you'll have files that can be recovered. Now, that's assuming that the backup file and the part 2 file created for that backup file are not both corrupted. There's worst case scenarios for everything, but for everything I would suggest to do is to verify periodically and to keep multiple backups. My suggestion for best practices is every week you do a full backup, and every day you do an incremental. That's what I've been doing for years, and it's kept me from having too many problems. Most of the problems, in all honesty, that you need a backup for are not machine related, or not error related. Not machine error related, I should say. They're human error related. Most of the backup requests are made, or most of the restore requests, rather, are made because, whoops, I deleted that directory. I didn't mean to. It's not a machine error. It's not a networking error or anything like that. It's just plain old human error. It's probably 95% of the reasons for backup.
And so what would you say are some of the most difficult or complex aspects of the problem space that Duplicity is dealing with?
I'd say the most complex that we deal with are people doing long strings of incremental backups. The way Duplicity works is every backup past the full backup is dependent upon the previous incrementals plus the full backup in order to rebuild the file that has been changed throughout your backup time between the full backup. So if you have a file or files that are constantly changing, like say a database file, we may back up 50 gig of it on the full backup and then 2 gig every night because that's all that's changed. But if you think, well, it's going to take me too long to do this full backup, I'm just going to run for a couple of months. Well, now you're relying on the integrity of the full backup and 60 incremental backups, all of which are required to be consistent. That can be a problem. Like I say, once networks make errors, machines make errors, sometimes we don't catch them, especially given the fact that they sit on a remote system. The file could have gotten corrupted on the way over. The file could have gotten corrupted over there. So that's the most complex one I have to deal with. We have a solution where we can try to work through that. We have manual mechanisms of rebuilding from the tar files, decrypting it yourself, compressing it yourself, and trying to build from the tar files, but problematic, very time-consuming, so it has to be an extremely important file. That's the most complex one, is really dealing with the human side of it that is not wanting to follow procedures, I guess.
Yeah, just like with most things in computing, the problems are dealing with people.
Yeah, we put the backup out there so that it's there in case you do delete your file, or in case your machine goes kablooey, or what happens. But we can guarantee that there will be, on occasion, errors, just because of the fact that you are going over a network and you are going to a foreign machine. Disk errors creep in and network errors creep in. I don't remember the exact numbers. They're in the billions of operations. So it's rare, very rare. But if you do a lot of work with computers, you'll get a bad file back from a storage provider. And nothing that you used will have reported problem.
And when I was doing the research for the show, I noticed that you've got a proposal for a new archive format to replace tar. So I'm wondering if you can just briefly describe the motivation for that and some of the design considerations that have been made.
What we need is a good way to do an easy indexing of the files. tar, you can go into it, and if it's local, it's very fast to do a tar, TF file name, and get an index of the tar file and so forth. We can get a list of the files by looking at the signature files, but what we really need is a better way to do the indexing, and we need a better way. People have really wanted to have something that will allow them to delete a file all the way back to the full backup. That's something I don't know that can be done without a client-server model or without having the file local. But the tar file has served us very well for now, and I am not inclined right now to change it. Proposal is good, but it does end up being something that other tools can't touch, and so you would have to end up writing something to recover that file. Whereas there are good tools to handle corrupted tar files out there, but a corrupted duplicity file that was a special format would have to be something specially written. So I'm more inclined to stay with the tar information format right now and work on a better complete manifest. So you could do a list of files that you have in your backup and a few other improvements like that, and I think you've got a complete product. So no, I don't think we will be writing our own format. There's just too many advantages to having something that in an emergency, in a situation where the file is corrupted or something like that, you can restore it with tools you already have or which are available immediately from the net. It's just a lot more work than I want to get into right now.
So are there any other topics that you think we should cover before we close out the show?
No, not really. I want to, if you don't mind, I'd like to say hello and thanks to Michael Terry and to Aaron Whitehouse and to Edgar Solden. They have been three of the primary supporters of Duplicity, and I'm probably leaving somebody out, but I don't have any notes in front of me, so my mind is, those are the three that do the most work on keeping this thing going, besides me. And I'd like to say thanks to them. They've done a lot of hard work. They've done a lot of frustrating bug chasing and frustrating user interaction. Very happy they took on, instead of having to do it myself.
So for anybody who wants to get in touch with you or follow your work on the project, I'll have you send me your preferred contact information.
Sure.
And with that, I'll bring us into the picks. For my pick this week, I'm going to choose the movie Passengers. I watched that recently with my wife, and it was a pretty interesting movie. Had a few interesting ideas around sort of ethics and the complications of space travel. Pretty well done movie. I enjoyed watching it, and I think that others would like it as well. So with that, I'll pass it to you. Do you have any picks for us this week, Ken?
I don't have a real pick for this week, per se, believe it or not, but I am in the process of catching up on a lot of old TV shows that I have not watched because I was so busy. I would recommend NCIS to anybody, I think, but do it on Netflix, not on commercial network. I'm willing to wait a year for the next series of NCIS to come out. It's a very good series. It's very well done. I have not seen a lot of movies lately. My taste in movies goes to science fiction, but a lot of times it goes to the weirder science fiction like Plan 9 from Outer Space and some of those B movies that are quite funny to watch, actually. Pretend to be serious, but they're quite funny to watch.
Well, I appreciate you taking the time out of your day to tell us more about Duplicity and the work that you've been doing with it. It's definitely a very useful tool and one that I rely on myself for all of my backups. So thank you for that. And thank you for continuing to support it. And I hope you enjoy the rest of your day.
Thank you, and you too.